These explainer videos are going to eventually work into examples, but I just want to hit a couple other things at the beginning of the semester here with calculus. And piecewise functions always seem to capture a student and just hold them down, and I think we should just talk about them really quick. So usually you get a formula like f of x equals x squared, and you look at the parabola that it creates. Maybe the axes are like here, maybe because it's x squared minus 8 or something. So at the bottom, here's the point 0, negative 8, and from there it climbs. Pretty obvious. But piecewise functions include different groups of functions into one thing. So let's say I'm going to make something at random. Let's say I take part of a parabola, and then I want to jump up a little bit and maybe make some kind of a sine function here, and jump down a little bit and then use a straight line or something like that. Because maybe we're looking at some barriers here where we're reading numbers, and maybe this is like something that happens in the wind at certain levels of stratosphere. Like maybe this is a certain altitude where wind has a certain behavior, and then it hits some kind of a barrier, and then the wind has a different behavior, and then it hits another barrier, and now it has a new behavior. There's all kinds of examples like this in the world. So I just want to walk through this really quickly because we are going to use this in calculus. Now, let's pick a really easy one. I'm going to pick part of a parabola, and then I'm going to pick a line like this. All right, and I'm going to give them some random formulae. Okay, so let's say the first one is f of x equals 1/10 x squared. So it's growing really slowly. And let's say like we're on some coordinate axes here somewhere. It doesn't really matter, right? It's all relative. But I am going to draw a little vertical line here to show that these are in the same spot vertically at this, let's call it A. It's an x value because it's a left and right value, but I'm just calling it A. Because x is for all of the inputs, right? X can be anywhere on here, and A is a certain spot that's measured by some value of x. So, okay. Now maybe the other one is f of x equals 5, right? And the y value here, whatever coordinate this is, maybe it's like 1, 5. This one over here is maybe like 2, 5, but the y value is always the same at 5. So we always want to notate where and why this is. So we're going to give them a domain, all right? And the way we draw that is for A, that's going to be a rough one. Let's say like for all x or something. And at this one, we'll say like x is less than or equal to a, because that represents this entire side of the function. Okay, and then on the right side, I don't want to get rid of that one. It's that x is greater than a on this side of the function. So what we're doing here is really we're just trying to say when you're greater than a, this is the function we use. When you're less than or equal to a, this is the function we use. So how do I know if it's a real function? How do I know if it's a real function? I'm going to remake it here real fast so I can write on it some more. Like say we have this here. Now we have this here. I'm going to draw it with a double dark circle for this example. We're going to use something called the vertical line test. So I should be able to draw a vertical line anywhere on here. And the rule is the vertical line test says you should only cross, I'll use red, should only cross your function one time. And notice here, this crosses twice because these are both closed holes. That means this is not a valid function. The vertical line test is the be-all, end-all of that. And so I want you to think about this more logistically. Like let's use an example and say something, okay, what's an input and an output that makes sense? Let's take height and age, right? Let's say like for the beginning of your life, you're going to start growing exponentially until you hit a certain age. It's different for other people, but let's just say it's 20. And then from that point forward, you might level off like this, and then you get to a certain age and you start doing this. Promise you, you do. So this is like on the y scale, your height, and on the x scale, your age. So if I make a function that says like f of age equals your height, that should make sense to you. But no single formula is going to represent this very well. It's much easier to draw like a piecewise function and say like, hey, when you're less than 20, it's a parabola. When you're greater than 20, it's kind of flat, whatever you want to define for that. And when you're greater than 60, it's shrinking. And we'll make a domain for that, etc. But I want you to notice your function here. The vertical line test will always just have one value on your function, which means it has the potential to be a valid function. It usually is. Right? But let's come up with something else. Let's say I have something that doesn't pass the vertical line test and try and read what that means. So if I have a sideways parabola, some kind of hyperbolic thing here, we see that the vertical line test fails. So we got a problem here and we got a problem here. So that means if I come to your age, let's say this is 10 years old, that says that you're both like 2 feet tall and 6 feet tall. You can't be two things. Not in this. So the input should have only one output. And that means this is going to be wrong. This is so not allowed. And the vertical line test is a great way to just visually inspect whether or not the logic of this function makes sense. That doesn't mean there aren't other things that will disqualify it, but it's a very fast way to try to do it. So the last thing with a piecewise function is, let's say I have a parabola that's going like this, and then I'll make a line here like this, and another line that goes like this maybe. You can do this all day. And when I do the vertical line test, you'll find that this is bad. It's okay to not have a value. It's okay to have one be open and one be closed because this is the only value that exists there. It took a skip, this is called a skip, which is a problem for your derivatives later, but it's a perfectly valid function. And when you look at this part, that's one input creating two outputs. That's no good. Okay, so a piecewise function, if you look right here, you know immediately this is bad. Make sure you get that, okay? And the best way to look at that is I'm going to give these some random x values here so you can see, like, here's an x value of 2 and here's an x value of 10. Now, if I'm making a domain up and I say, you know, this function for x is like x squared if x is less than 2, and it's 5 if x is, I wrote that kind of funny, if x is between 2 and 10. This is what between looks like. That's the verbiage for that, right? This is greater than one or less than the other, but it means between. And then it's like negative x squared of some kind when x is greater than or equal to 10. So when you're looking at the domain, notice something here. When x is less than 2, when x is less than or equal to 2, this is okay. Okay, but when x is less than or equal to 10 and x is greater than or equal to 10, this is not okay, because that doesn't pass the vertical line test. So looking at the domain and seeing this less than or equal to and greater than, etc., pay attention to these symbols, because you can quickly look at the domain and say, this can't be a function. The greater than and less than equal to stuff isn't really matching up. It takes some practice to look at. But really, piecewise functions are just a combination of other functions to make some kind of measurement more accurate without coming up with an insane, can't think of the word, an insane function to try and match it up all in one. And that's really all you need to get here.